Hello, my name is Hadi Farhangi on Basics of Statistics, Linear Regression. Topics of this video: Introduction, Linear Regression Equation, Multiple Linear Regression, and Application of Regression. Next topic, Introduction. Variance is the average of square distances from the mean. Well, sort of. Here's the formula for the variance. We find the distance from the mean, square it, and average it, but instead of n, we have n minus 1. Covariance is similar to variance, but for two variables. Here's the covariance of x and y. We sum the distances from the mean of two variables and divide it by n minus 1. Coefficient of correlation is the normalized covariance. As you can see in this formula, R is covariance divided by a square root of variances. Trend line in a scatter diagram shows the linear regression line. Linear regression line is the line with the least square of errors. Here's the figure that shows the scatter diagram of units sold and price, and the trend line is shown in red. This video is about how to find that linear trend line. We call it linear regression. Next topic, linear regression equation. The regression line, similar to any other line, can be drawn by knowing its intercept and its slope. Here's the regression line. A line in general, if you know intercept A0 and the slope A1, you can go and draw it. You find the intercept, and with that slope, you go up. The regression line will be y hat equal to A0 plus A1x. And y is called dependent variable, and x is called independent variable. And in the regression equation, we use y hat instead of y because it's approximation of y. The trend line, regression line, and some example data can be seen in this figure. There's a scatter diagram of x and y. There's a trend line in red, the scatter points in green, and you can see the distances between these points and the trend line. I show it with errors E1, E2, all the way to E5. This figure shows these errors as a distance between actual y values and the one in the regression equation. If one minimizes these errors, we get the values of a slope and intercept as follows. A1 is R, a square root of SYY divided by SXX. SYY variance of Y, SXX variance of X, R is the regression correlation coefficient. And then A0 is Y bar minus A1 X bar. So you first calculate A1, then A0. Note, first A1 should be calculated, then A0. 2, because the errors are being minimized, the method to find A0 and A1 is called least square method. 3, SXX, SYY, and SXY and R can be calculated using the table method that we saw in the previous video. More on linear regression equation example. A sales manager gathered information on the number of sales calls made and the number of copiers sold for a random sample of 10 sales representatives. Data is gathered in the table at the right. Find the linear regression to express the relationship between the two variables if number of calls is independent variable. Here's the data. We have number of calls and number of sold copiers for 10 representatives. Every row shows a representative. There are 10 observations in the table, hence n is equal to 10. Variable number of calls in the independent variable x, and variable number of sold is shown with y. Based on the data, one can calculate x bar 22, y bar 45. To calculate a regression equation, one has to know A0 and A1. To calculate them, one must first calculate R, covariance, and variances. The calculation proceeds as follows. We create a table that we find the distance of x from x bar, y from y bar, then square those distances to get the variances, then multiply those distances to get the covariance. And we use the last three rows to calculate variances and covariance. SXX is the summation of the column x minus x bar divided by 10 minus 1, which is 84.44. SYY is the variance of y. The column y minus y bar squared is used. 205.56. SXY covariance is the summation of last column divided by n minus 1, which is 100. R is calculated as SXY divided by a square root of multiplication of variances. If we do the calculation, it will be 0.759. A1 is R times the square root of SYY divided by SXX. As you can see, it is 1.18. A0 is y bar minus A1 x bar. If you put in those calculations that we know from the data and previous tables and calculation, it will be A0. So regression equation is 19 plus 1.18 times x. The order of calculation is very important. First, variances and covariance, then R, then A1, then A0. And then you will end up with linear regression equation that is shown with y hat. You substitute A0 and A1 in that equation, and you will end up with linear regression equation. Always, for all data, these are the steps you have to follow. Next topic, multiple linear regression. Consider independent variables x1, x2 to xk on one hand and dependent variable y on the other hand. The linear regression equation for these variables is y hat equal to a0 plus a1 x1 plus a2 x2 plus all the way to ak xk. Here, the difference is that we have multiple x's, not just one column, multiple column for x's. That's why we call it multiple linear regression. To find the coefficients of multiple regression, one can use Google Sheet. Here is a function to type in a cell of your choice, lin st range of y, comma, range of x, comma 1, comma 1. This function will return a0, a1, a2, all the way to the ak. If you have one variable x, then a0 and a1. The Google Sheet will return coefficients in the first row. The last element of the first row is a0, and elements 1 to k of the first row are a1, a2 to ak. And r square appears as the first element of the third row. Here's an example. The following table shows the average income, population, travel time, and land mass of 10 states. Assume income is dependent variable, y, and the rest are independent variables. Find the linear regression and R for this data. Here's the data in the table. We have 10 states, every row is for a state, and the income, population, travel time, and land for every state is recorded in every row. The answer, assume y is income and x1 is population, x2 travel time, x3 land mass. The linear regression is to look like y hat is equal to a0 plus a1 x1 plus a2 x2 plus a3 x3. Three of them because we have three independent variables. Using Google Sheet, you will get the result as the rows 13 to 18. The first column shows coefficients, a1, a2, a3, a4, a0. A1 is 0.0139, A2 is 847.2, A3 is minus 0.00011, and A0 is 6119. And the R square is in the third row, 0.0963. Now the regression and R can be written as y hat is equal to 6119 plus 0.0139x1 plus 874.2x2 minus 0.00011 x3. And we have the R square. We can calculate R, as you can see in the calculation here. So R square based on the first element of the third row is 0.0963. And if you find the square root of that, R will be 0.31. Next topic, application of regression. There are at least two applications for regression in general. Application 1, finding the relation between variables for predicting. Application 2, find out which variables are significant in predicting y variable. So application 1, prediction. Assume a regression equation is this: y hat is equal to a0 plus a1x1 plus a2x2 all the way akxk. If a0, a1, ak are calculated and known, and x1, x2 all the way to xk are known, then y can be predicted as y hat by substituting these values in the regression equation. Here's an example. Assume the regression equation is y hat equal 100 plus 30x, and x is in the range of 10 to 50. A, predict y if x equal 15. B, predict y if x equal to 40. C, predict y if x equal to 60. And here's the answer. For x equal to 15, it is within the range. One can use the regression equation and plug in the value of x. Y hat is equal 100 plus 30x. Substituting x equal to 15 for part A is 100 plus 30 times 15 is 100 plus 450, which is 550. For x part B, x equal to 40, it is within the range. One can use the regression equation and plug in the value of x. Y hat is equal to 100 plus 30x. X is equal to 40. Substituting 40, it will be 1300. For the part C, x equal to 60, it is not within the range of 10 to 50. This means the regression equation cannot be used for prediction here in the case of C. Application 2, significance of variables. One can calculate p-values of variables and see if the regression relation is significant. I will not explore this in this video, and I will leave it to the future videos.